This lesson shows how to solve disjunctions, compound inequalities joined by the word or. Solve disjunctions by solving each of its two parts. On the left, begin by subtracting 8 on both sides for 3x less than negative 6. Then divide both sides by 3 for the first part of the solution, x less than negative 2. On the right, add 8 to both sides for the second part of the solution, x greater than 4. Joining both parts together, the solution to the disjunction is the set of numbers less than negative 2 or greater than 4. Then graph the solution. Any number less than negative 2 or greater than 4 is the solution to the disjunction. When you write a disjunction, the less than inequality must be on the left and the greater than inequality on the right. And the number on the left must be smaller than the number on the right. The statement should match the graph. There are two boundary checks. On the left, rewrite the inequality as an equation and substitute the left boundary x equal negative 2 for 3 times negative 2 plus 8, which is negative 6 plus 8, which is 2, and the left boundary checks. On the right, rewrite the inequality as an equation and substitute the right boundary x equal 4 for 4 minus 8, which is negative 4, and the right boundary checks. For the inequality check, use any convenient value in the solution set. On the left, since any value less than negative 2 is the solution, use x equal negative 4. Substitute negative 4 into the inequality. On the left, you have 3 times negative 4 plus 8, which is negative 12 plus 8, which is negative 4. On the right, you have negative 4 minus 8, which is negative 12. Notice that the left-hand statement is true, while the right-hand statement is false. Because of the word or, if one of the statements is true, the entire statement is true, and the solution checks. You could do another check. On the right, since any value greater than 4 is a solution, use x equals 6. Substitute 6 into the inequality. On the left, you have 3 times 6 plus 8, which is 18 plus 8, which is 26. On the right, you have 6 minus 8, which is negative 2. Notice the left-hand statement is false, while the right-hand statement is true. Because of the word or, if one of the statements is true, the entire statement is true, and the solution checks. When solving inequalities, it's important to graph and check the solutions to verify they make sense. For example, this solution is written backward because the greater than inequality is written first. If you turn it around, you have a good statement. All the numbers less than negative 1 or greater than 4. For this solution, the number on the left is greater than the number on the right, and the actual solution is all real numbers. To see why this is true, graph each part of the disjunction, x less than 2 or x greater than negative 4. Notice the entire number line has been shaded. Any number on the number line would make at least one of the statements true. So the solution is all real numbers. For this solution, both inequalities are the same. They're both greater than inequalities. To determine the real solution, graph each of the inequalities, x greater than negative 3 or x greater than 2, and test some numbers. A number like negative 6 doesn't make either statement true. A number like negative 1 makes the first statement true. And a number like 4 makes both statements true. So the real solution is x greater than negative 3. Since any number greater than negative 3 makes at least one of the statements true. This lesson showed how to solve disjunctions, compound inequalities joined by the word or. And this lesson was brought to you by the Math Fun Academy. Its continuing mission to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before,